This video will talk through the skill of rationalizing the denominator. A radical is not completely simplified if a radical, meaning a square root symbol, remains in the denominator. So this video is just going to show you how to take these expressions and manipulate them so that the denominator is a rational number as opposed to an irrational number. Now something like number 1 is pretty simple. Well, here's a few basic rules. The square root of a over b under the radical is equivalent to the square root of a over the square root of b broken into two pieces. And a square root of a times itself is just simply a. When you multiply a radical times itself, then the answer is the radicand. The simplified answer is just the radicand. So something like number 1, since 25 is a perfect square, this would be radical 15 over 5. I could just leave it at that. Radical 15 over 5, since 25 is the perfect square. And then looking at the next example, I could say the square root of 25 is 5, and then that would be over radical 15. So let's use this as a good learning example. I could get a decimal answer for that, but if the instructions ask you to present it in reduced radical form so that the denominator is a rational number as opposed to an irrational number, what you would need to do is multiply by 1. But 1 is going to look like the square root of 15 over itself. And when I multiply this out, I have 5 radical 15. And remember my property, a square root times itself is just the radicand. Radical 15 times itself is just the integer 15. And then I would compare, if I can simplify, I do so. So my simplified answer for this would be radical 15 over 3. Now, the decimal representation of all of these, this decimal answer, and this decimal answer, they're all the same decimal answer. The skill involved, though, is to rewrite the expressions so that the denominator contains a rational number as opposed to an irrational number, which would be a radical that's not a perfect square. Let's do a few more. Okay, let's go back. Let's look at number 2, the next 2 examples. So here I've got radical 7, and my denominator just happens to be a perfect square. So if I rewrite it like that, I'm cleared. I'm done. The next one, the perfect square is in the numerator. So here I'm going to have 6 over radical 7. So the way that I would manipulate that, I would multiply by radical 7 over itself. And then I would have 6 radical 7. And then my denominator would be the rational number 7. Let me go down to the next row, and we'll pick a few down here. Okay, let's do the simple ones with numerators of 1. They're the easiest learning examples. So here, if I look at radical 1/5, problem right here. So the square root of 1 over the square root of 5 is really just 1 over radical 5. So if I need to express that with the rationalized denominator, I would multiply by 1, but 1 is going to be radical 5 over itself. So now my numerator becomes the square root of 5, and my denominator becomes the integer or rational number 5. So when the numerator is 1, it's actually pretty easy to figure out what the rationalized denominator would look like. In this particular problem, it's just simply going to be the square root of 10 over 10. So we could even go on and make a little property and say if I have this example, 1 over a, and it's underneath the radical, then the rationalized version of that would look like a, square root of a over a. That could be our little property. But that's only going to hold when my numerator is 1, to go ahead and make that leap. Okay, let's do a few more on the video just to give you some practice with this. And let's do something like number, now let's do this and then we'll stop here. Okay, so here I have radical 27 over radical 8. 8 is not a perfect square, or 8 has a perfect square factor, but I think I'm just going to do it like this. I'm going to multiply by radical 8 over radical 8, and that's going to give me a denominator, the denominator that I'm looking for. And now my numerator, I'm going to multiply everything here, But when I do this, I'm going to break it down so that I can see my perfect squares. 27 is 9 times 3, and 8 is 4 times 2. So my perfect squares here are 9 and 4. So as I simplify this, and I'm going to come to the other side of the board, the square root of 9 is 3, and the square root of 4 is 2. And then under the radical of my numerator, the 3 and the 2 remain, coming together to give me the 6. And then my denominator is 8. So I would simplify what needs to go away here. Let's see, taking out the 2's. So my simplified answer is going to be 3 radical 6 over 4. And I will stop the video here.